So welcome back. So now we've spent a lot of time about how to store data, what data syntax looks like, XML, JSON, YAML, CSV. We saw that we can parse data into memory into trees or data frames. We saw that we can validate it against schemas when we have collections or millions or billions of documents. And now it's time to finally start querying the data. So now we start the serious part. Okay. Well, I'm not saying the rest wasn't serious, but this is like extra serious. So where are we? We've covered all of that. Wow, that's half of it. Right, that's nice. Storage, encoding, syntax, data models validation. Now it's time to proceed to the next stage, processing. Okay, and now it's going to, I hope it's going to be fun. So this is something I actually sometimes do in class, but now time doesn't permit, but in some years I actually do it in class. I use the Easter break to hunt for Pokemons. I found hundreds of them. But now my problem is that I need to sort them and figure out how many of each I actually found. Of course, I could do it alone and count. Maybe it would take me like 1 or 2 hours. I don't know. I'm a bit slow. Is there a way to make this more efficient? And in fact, yes, and I actually use the class to do this. So what I do typically is that so this is what I want. I want to have how many of each Pokemon I have. So what I do is that I bring them to the class in bags. So I have 10 bags typically, and I just create each shards. It's technically partitions or chunks or shards or splits of my Pokemon data set. And then I distribute them over to volunteers, literally. So I give to 10 of you these bags with the Pokemons, right? And then I ask you, okay, how do we together count them in this way? And so what happens is that the first 10 volunteers who each get a bag, they are going to, so this is one person, and they're going to take the bag and then write on a piece of paper that I also supply to fill in the numbers. So there is one of the, I don't know the names, I know the yellow one is Pikachu. The other ones, I'm not sure, but there's 1, 3, 1, 2 Pikachus, 1 and 1. Do you know the names of the others? Maybe not all. Okay, but anyway, this is what these 10 volunteers are doing, and then we have, as a result, this piece of paper. Now, what happens is that I ask for more volunteers, 8 people, and these 8 people will be assigned specific Pokemons. Maybe 1 Pokemon, 2 Pokemons, because I have 10 of them and 8 people, so obviously some people will get 2 Pokemons. But basically, what will happen is that the people who prepared this intermediate data on the shards of Pokemons, they use scissors in order to cut it into, separate the Pokemons. And then there's usually a big mess that takes 5 minutes to sort out, where the people, the volunteers for task 1 and the volunteers for task 2, they have to each meet each other, because every time you need to give the Pikachu Pokemon to this student right there, right? So this is quadratic complexity, as you can imagine. So that's called shuffling. So after this person here, who is responsible for Pikachu, has received from all the stage 1 volunteers, all the Pokemon, the Pikachu cards. So there's a 1, there's a 2, there's a 1, there's a 3, there's a 1. What do I do now? I sum them, exactly. So this is it. That's the task for this second stage of volunteers. We add them, and now we have Pikachu 8. Then we gather everything. That's the end, that's quick. And now I have my count. Of course, that's all made up. There's more than that in reality. But that's pretty much it. Who understood what went on? Who is convinced we get the proper counts? Okay. Well, that's MapReduce. Technically, I could end the lecture here and let you go and say, okay, this is MapReduce, we're done. But of course, I'm going to show you a bit formally and so on. But basically, that's it. That's MapReduce. And this is, in fact, extremely powerful. It's very simple. It's just these 2 phases. That's actually called, this is called mapping here. And this is called reducing here, with the shuffle in the middle when we just make sure to receive the Pokemons. But surprisingly, in spite of the simplicity of this, it is incredibly generic. And there are an incredible number of problems, of querying problems, that can be expressed with something that simple. This is what's amazing about it. And this is called MapReduce. It grew in popularity. So we have now, getting back to the big data aspect, we have a storage as a file system. We have HDFS, for example. We have S3, we have Azure Blob Storage, so we have data in there. The data might be organized in text files, right, like this. Billions of lines, I insist, right? Or we could have CSV files like this, right? I could have billions of lines like this, looking like CSV. I could have also some more customized formats. That's not really a standard. It's basically taking a bit less space than CSV, but you can still figure out how to parse it and make sense of it. We can also have use format with a space here. I have a year on the left and then some obviously a duration on the right. I can also have JSON lines format. I think I've already showed you that one, right? One JSON object per line, but we can have billions of them. And I can even validate them again, the schema. You can probably, who would be able to give me a JSON schema for that? Probably would, right? Year, integer, date, duration, blah, blah, blah. So you can figure out a JSON schema. It's basically a data frame. By the way, what is this data set? What is there in there? Another question, what is the year 2023? What should I add there? Yeah, that's just the Zarsilute bug. You probably recognize it. So terrible year this year, 57 minutes. We're going to have a very, very cold summer. Obviously, Canton Schwyz invited. But anyway, that's the data set. Now extending it every year with the new duration. And you see how useful it is to have a heterogeneous structure, because now we can even account for the year 2020. For the first time in a century, there was no Zarsilute, but that's fine. We can just omit the fields there. Anyway, I can also store it in a binary, because maybe I had the beautiful idea of storing it as Parquet, because that takes less space. Because of course, we have been celebrating Zarsilute for billions of years, and that can take petabytes to store all of that. Now, typically, I presented that to you as files that have 1 billion lines. Typically, when you store that in HDFS or S3, you're not going to store it as a single huge file. Typically, you're going to store them as multiple files, 10 files, 100 files. And very often, you're going to call them with increasing integers, part 1, part 2, part 3, and so on. So I'll get back to that. So typically, we partition into what is called a shard. A shard is not the same thing as a block in that case, right? A shard can be several gigabytes, but it's itself divided in blocks by HDFS if you store it on HDFS. All right. Then we even have HBase that we can store things in. For example, as a table that would look like this. I could even store it as XML within an HBase table, because I told you in HBase you can also put whatever you want in the cells, up to 10 megabytes per cell. So we could also have XML that is valid against that schema. You see how everything fits together now. It's exactly the same data. And now it's time to query it. It's time to query it. However, it's 10 a.m. and that's already the end of this lecture. So next week, I'm going to now take back these Pokemons, get back to the Pokemons example, but now we are going to do it with real data. But as I said, if you understand the Pokemon thing, you understand MapReduce already. All right. Before you leave, I just want to make sure that you've been following. I really try to take the time to make sure of that, but I always want to get a bit of a feeling. And again, the exercises are the way to go now. You have to really solve the exercises to strengthen that knowledge and make sure that, that you get everything. Okay, we have a majority above 80%. So this week, the exercises will be about data models and validation, JSON, JSON schema, XML schema. So they will be released probably tomorrow with the quiz. And next week, I'll continue with MapReduce and this formal approach to MapReduce. Thank you very much, everybody. Have a good rest of the day. Enjoy the exercises, and I'll see you next week at 8 a.m. for the continuation of the lecture. Goodbye.